Welcome folks, I wanted to show you a very quick tutorial on how to use the OP-27 using ORCAD. Basically this tutorial is used for our circuit laboratory course at Washington State University, but I want to show it with you on YouTube so anyone who is interested in learning how to use that can use it. So I will start by loading the CIS capture, so I'll do that and then I will have it popped up. I will start with a new project, so I will say file, a new project. I will make sure that I use the PSPICE option. I will give it a name, lab number 8_1. Then I will do OK, and then I will make sure that it's a blank project. I will click OK here. And the first thing we want to do to the schematic is we would like to add the OP-27 library. If we don't have that, we need to add it. So I'm going to come here to place part. I will click on it, and then as you can see here, I don't have the OP-AMP library, so I'm going to basically say that I'm going to add the OP-AMP library. So I'm going to come here and I'll say that add library. Make sure that this particular ORCAD version is the 17.2, because 17.2 will allow you to use the OP-27, which is similar to the one that we use in the lab. So I'm going to scroll down for OP-AMP library, which is the OP. Keep scrolling down. Here we go. So I will look at the OP. Keep in mind that it's under the PSPICE directory. So I will do the OP. I will have open, and then now I can write OP-27. I have it here, so I'm gonna basically select that. So double click on it. I will have it here. Let me zoom in a little bit to show you the polarity. So you can see that the non-inverting input of the OP-AMP is on the top. I want to keep it at the bottom because this is the way that we usually do the convention. So I'm going to right click on it and I will do mirror vertical, and it will bring the non-inverting input at the bottom and the inverting input at the top. So this is the way we usually like to draw the OP-AMP circuits, just to be consistent with the drawings of most textbooks. So the first thing you need to do when you wanted to connect the OP-AMP is to have the rail-to-rail power supplies. So I'm going to zoom out a little bit here, and then I'm going to add 2 voltage sources. So I'm going to say that VDC, DC voltage sources. Make sure that we select all the libraries here. So I will have VDC sources. And now I'm going to come at the bottom here. I will do the first one, and then I'll make sure that I connect ground on the bottom one. And then instead of connecting this voltage source directly, I will use the port. So I will place port. So I will do it for both, which means that input and output. So I will use it as a port. It will basically make it simpler to draw the circuit. Now this port basically in ORCAD, in the professional ORCAD, if you want to do the PCB design for your circuit, it basically says that this input output port, but here I'm using it as a node. And then I'm going to power this power supply with 12 volts, so I will say that it's plus 12 volts, and I'm going to give it a name. This port I will call it VCC. Double click on it and I will say that it is VCC. And now I'm going to also connect this VCC to the VCC input. So I will do control copy, and then I'm gonna paste it. But to paste it, I will come to this node and I'll connect it to the V plus terminal of my OP-AMP. I'll do control V. That's basically for paste. And now I have connected the 12 volts to this side of the OP-AMP. Let me zoom out again, and now I'm gonna basically copy that, control C, then I will paste it, control V, and all what I have to do now is make this to be the negative 12 volts. So I will come to the value, I will make it negative 12 volts, I will do a minus in front of the 12, and then I will call that VEE. So I will change the name by clicking on it, and then I will change it to VEE. Again, I will copy this particular port and I will connect it to the top of the OP-AMP, and this basically says that I have named it to VE. So negative 12 volts are connected to the V minus and positive 12 volts are connected to the V plus. And now I'm gonna draw the remaining of the circuit. So to draw the remaining of the circuit, basically I'm going to have a resistor R. This is gonna be R1. So R1 gonna be connected to the inverting input, and then I will have R2 to be connected to through the feedback. And now I'm gonna do the wiring for that. So I'm gonna connect R1 to the OP-AMP and R1 to R2, and then also let me zoom out a little bit. I will connect R2 to Vout. I can also add a load resistor if I wanted, so I'm gonna add another load resistor. I will call it RL. So what I will do is I will click on the R to rotate it. So I will click on the R, and here I rotated R3, and I'll give this to be 10k ohm resistor. I will make this resistor to be 20k, which is R2, and R1 I will keep it as 1k. Now I'm gonna connect the rest of the grounds. So RL gonna be grounded, and also non-inverting input will be grounded, so I will connect it like that. And then let me bring this a little bit. We'll change the name of this resistor to RL. And finally what I need to do now is I'm gonna apply the V sine wave. So I will apply V sine to the input. So this is gonna be inverting amplifier with a gain of 20, because R2 is 20k and R1 is 1k, so the gain of this circuit gonna be negative 20. And then I'm gonna also connect the ground to this voltage source. And now the values here, V off, that stands for offset, that's DC offset. I will make it 0. I'm not adding any DC offset to the circuit. Here I will have the amplitude of the sine wave gonna be 100 millivolt, and then the frequency I'm gonna use 1000 hertz or 1 kilohertz. And then the AC component we're gonna say is 0, because I'm gonna only do transient analysis here. I'm not gonna do AC response, which is probably something that you haven't learned how to do at this point. And in this case, I'm assuming that I'm not gonna do any AC response. So this is the circuit. I'm gonna save it. Now I'm gonna define the simulation. So I'm gonna click on new simulation, and I'm gonna call it sim1. You can give it any name. I always call it sim1, simulation 1. If I want to create another one, I will call it sim2 and so forth. So it's going to be a transient response, so I'm going to look at the transient response of it. The frequency here is 1000 hertz. That means each 1 millisecond going to give me 1 cycle. So I'm going to do about 10 cycles. I will say that is 10 milliseconds. It's extremely important to know what's the runtime is, and the runtime is basically based on what's your frequency is. If you're using 1 kilohertz, 1000 hertz, then each 1 millisecond going to be 1 cycle. Here I'm going to show 10 cycles. This is going to be 10 milliseconds. And then when the simulation start time will be, I will say it's going to start at 0 second. Finally, the maximum step size, that's important. It will tell you what's the resolution of your simulation is. So I'm going to say it's going to be 1 micro. This is maximum step size. So at minimum, you're going to have 1000 samples per cycle, right? Because this is a numerical method. Basically, the way it goes is that as we apply the sine wave to the input, the maximum step size to simulate the circuit is going to be 1 microsecond. It's going to be about 1000 samples in 1 milliseconds. At worst case, it can be higher than that, because this is the maximum step size. So the numerical method for ORCAD is kind of adaptive. So the step size will change adaptively based on the circuit, but the maximum step size is going to be 1 microsecond. Something you need to know, because if you end up with non-clean signal, highly likely your maximum step size is too big. In fact, that I would recommend you to play with it and see what happens if you use a very big step size. Anyway, so we're going to do apply here. Okay. Now I'm going to add the output voltage. So I'm going to measure that by doing the probe here. And also I'm going to add another probe at the input. So I'm going to measure the output and the input as a function of time. Then I'm going to run the simulation. And let's see what we have. So we should have a gain of -20. This is inverting amplifier, and the gain gonna be -20. So let's see what our gain was. So clearly that you have a peak value of 2 volts, and we know that the input has a peak value of 100 millivolts. So clearly that the gain gonna be 20, and then you can see that when the input signal is positive, the output signal is negative. So that's a gain of -20, and you can see that when the input signal is negative, that means the output voltage was positive. So the gain is -20 here. Now we can convert this easily to the inverting amplifier. So I'm gonna basically come back to my schematic, and to say that I'm gonna change the circuit to the inverting amplifier, all what I have to do is basically move this voltage source to the non-inverting input and short circuit this voltage source at the inverting input. So to do that, I'm going to do Control X. That's basically says that let's cut, and then I'm going to short the input here, and then I'm going to remove that. I'm going to do Control V, and I'm going to connect my input voltage to the non-inverting input. So now the gain gonna be +21 because the gain is 1 plus R2 over R1. Keep in mind that RL is independent of the gain because actually the feedback is the one that is causing the gain. So let's resimulate the circuit and see what we have. So we're gonna we save the circuit. Now let's simulate the circuit and see what we have. We should have a gain of +21. So you can see, for example, when the input signal is positive, the output signal was positive. So the gain becomes non-inverting gain, right? It's basically positive when the gain is positive. And you can see that V out will be a little bit higher than the 2 volts. In fact, that is going to be 2.1. Each of those divisions are 0.2, so it's half the way through the first minor division. So this is 2 volts, and then halfway through it's going to be 2.1. So clearly that the gain is +21 volt per volt. So basically, to come to the circuit and you say that you want to convert it from the inverting amplifier to the non-inverting amplifier, just remove the voltage source from the inverting side to the non-inverting side and short circuit the inverting side. Becomes non-inverting amplifier. Anyway, you learned how to simulate the circuit in ORCAD. So the first thing you want to do is make sure that the library is added, and then connect the circuit as you want, and then you can simulate the circuit. So we will build the circuit in the lab, in the laboratory, and we will verify it, and we will compare it to the simulation result. You should get very close values to what we obtained here. I hope you enjoyed this video. It was very short, very quick, and that will help you. And please share and subscribe if you like my videos. I thank you for that.